Okay, this is mathheals.com, where you can find more links to math YouTube and computer science YouTube videos. Let's take a look at differentiation and integration of vector-valued functions. And our first problem here. I should get my tablet running, I guess. There we go. We got r of t is equal to t minus 2 I plus t squared j, and t naught is equal to 1. Now they're wanting us to sketch a plane curve represented by the vector valued function, and we'll get to that in a minute, and sketch the vectors r of t naught and r prime of t naught. So we need r and r prime. So r prime, take the derivative, and taking the derivative is the same as the way we did derivatives before, except we're going to take the derivative of each component function. Derivative of t minus 2 is 1, so I got 1i, or just I, and t squared becomes 2t and then j. So that's our derivative. Now we're going to need to plug in t naught, so to evaluate those. So we'll plug in t naught into our r. T naught, they say, is 1. So we'll put 1 in for t up here. So we're going to have 1 minus 2i plus 1 squared j, which gives us negative I plus j. Now we're going to plug t naught into our derivative, and again t naught is 1, and our derivative was I plus 2j. There's no t in front of the I, so the I just carries along, plus 2 times 1 j. So that gives us I plus 2j. And this sketches the plane curve. If we look at this, the x is whatever's before your I, so we got x is equal to t minus 2, and y is what's before your j, so y is equal to t squared. Now we start with the one with the smallest powers on the t, which is the x equals t minus 2, and we want to solve for t. So I take negative 2 over, and we get t is equal to x plus 2. We're going to now plug this into y is equal to t squared. So we said t was x plus 2, so we got y is equal to x plus 2 squared. Graph-wise, this is a parabola, and remember when you got a number inside with your x, it's shifted left or right, opposite what you think. The plus 2 would make us think it goes right 2, so it really goes left 2. Like this. And let me see, if I put negative 1 in here, then that'd give us a positive 1. And that's our graph, more or less. Okay. Actually, let me do one more point, just to be a little bit more precise. Okay, if I put 0 in for x, then I get 4. So let's see, 2, 3, 4. There we go. By symmetry, this one's going to look like this right here. Okay, so that's our graph of our vector valued function. But then we want graphs of r of t naught and r prime of t naught. Now r of t naught, they want us to start at the origin. Now I'll do this in red. So I'm starting here, and r of t naught is negative I plus j, so this is negative 1 on the x and positive 1 on the y, which would be the right here. So that's this one right here, r of t naught. Now r prime of t naught, they want us to, where we left off here, they want us to use this next vector. They want us to graph this. So we got I plus 2j. I is our x, so this means we're going to go right 1 up 2. So right 1 up 2 would be right here. Now this is tangent at this point right here. So that's what that gives us. Okay. To do this on our graphing utility here, and I know you can't see this real well, do window 2 dimensions. Actually, probably can't see it at all. And I'm going to choose equation and number 2, parametric. It comes up and asks us for f of t. F of t is whatever's before I, which is t minus 2. So t minus 2. Then it asks us for g of t, which is whatever's before your j, which is t squared. And I'm going to say, here, negative 2, I guess, and positive 2 for those. Then click OK. Okay, there's our graph. Now, if I choose equation, segment, and then choose xy, it's going to ask us from where. So x1 is 0, y1 is 0. That's our origin. And then where we're headed to. Well, remember, for r of t naught, we had negative I plus j, so that's negative 1, 1. So I go negative 1 for the x2, and for the y2, I put in a positive 1. Now I'll click the, down here in the arrows, I'll click the little radio button next to the P2, and the arrow size I'm going to change to 14, make it a little bit bigger, and then click OK. And you see it's going out from the origin to there. Now from where that one left off, we want to draw another vector. So 1 plus 2j. So I'll do equation, segment, xy. Now this one's left off at negative 1, 1. So x1 is equal to negative 1, y1 is equal to 1. And then it's going to go right 1 and up 2. Now this is based upon where it left off. So we're at negative 1, we go right 1. Negative 1 plus 1 gives us 0, so x2 is 0. And we're going to go up 2. And we're at y is equal to 1 now, so 1 plus 2 gives us 3. So it'll be 0, 3. Now I'll do a arrow on P2 and click OK. You see the arrow going over here. Now, if I want to save this, I could do a file, copy to clipboard. Oh, wait, I lied to you. File, bitmap to clipboard, and then go into Word and paste that in. And then you could print that off if you want to turn that in. I'd recommend using some kind of utility like this for coming up with your graphs. They'll be much cleaner than trying to do it by hand. Okay, let's look at another one. Let's look at number 2. Okay, so r of t is equal to 2 sine t, 3 cosine t, and t naught is equal to pi over 2. Same instructions. So we need r of t, which we got, and we need r prime. Now this is another way of writing the vector valued function. So I could write this as 2 sine ti plus 3 cosine tj. So I'm going to leave it in this format just so you see it. So for our derivative, r prime Derivative of sine is cosine, so we have 2 cosine t. And derivative of cosine is negative sine, so this will be negative 3 sine t. Now we want to plug in t naught, so we got r of t naught. So we'll put in pi over 2 for t. So we have 2 sine pi over 2, 3 cosine pi over 2. Now sine pi over 2 is equal to 1, so this is 2 times 1, so that's 2. Cosine pi over 2 is 0. 0 times 3 is 0. So we have this. We also need to take that value and plug it into our r prime. So we're going to plug in t naught, which is pi over 2, into r prime. So we're going to have 2 cosine pi over 2, negative 3 sine pi over 2. Now cosine pi over 2 is 0. 0 times 2 is 0. And then sine pi over 2 is 1. 1 times negative 3 gives us negative 3. Okay, come with our graph. If we look back at our original vector valued function, our component functions, this is x. So we got x is equal to 2 sine t, and y is 3 cosine t. Now divide both sides by 2 here, and we got x over 2 is equal to sine t, and y over 3 is equal to cosine t. Okay, now if we square both sides, I'm going to have x over 2 squared is equal to sine squared. And over here I'll have y over 3 squared is equal to cosine squared. So that gives us x squared over 4 is equal to sine squared. And this gives us y squared over 9 is equal to cosine squared. Now I'm going to add the left sides together. So I'll add the x squared over 4 plus y squared over 9. So I got x squared over 4 plus y squared over 9. And I'll add together the right side. So I got sine squared plus cosine squared, which gives us x squared over 4 plus y squared over 9 is equal to 1. Well, this is an ellipse. Now, since there's a 4 below my x squared, we take square root of it, which will give us 2, and we'll go to x equals 2, put a dot, and x equals negative 2, and put a dot. Now, the number before our y squared is a 9, so we take square root of that. Square root of 9 is 3, so I'm going to go to 3 on my y-axis and put a dot, and I go to negative 3 on my y-axis and put a dot. And I'm not very good at graphing the ellipse, so use your imagination. That's supposed to be an ellipse. Okay, now we want to graph, to put on our graph, r of t naught. So that'll be 2, 0. Now this is x and this is y, so it's going to come out to here. Now this is 0, negative 3. So based upon where I left off, 0, this is x, so x doesn't change, but negative 3 is our y. So it's going to go down 3. And you can see it's tangent at that point. Let me save this. This is diff and integration of vector valued functions. h01.pdf. Now let me double check that title there. Yeah. And save. Okay. So let's look at our next problem. Number 3. This one's in 3 dimensions. So we got r of t is equal to t squared I plus tj plus 4k. And t naught would equal 2. And it says sketch space curve represented by the vector valued function, and sketch the vectors r of t naught and r prime of t naught. So we need r prime, so let's find that. So derivative of t squared is 2t I. Derivative of t is 1, so this is just j. And derivative of 4 is 0, so 0 times k disappears. So we're just left with this. Well, I want to plug in my t naught, and t naught is 2 in this problem. So everywhere we have a t, we're going to put in 2. So I'm going to have 2 squared I plus 2j plus 4k, which gives us 4i plus 2j plus 4k. Now I want to plug it into our r prime. Plug 2 in for t. This one we have a t here, so we got 2 times 2 I. And j, there is no t, so it's just j. So that gives us 4i plus j. Well, I'm not gonna sketch these by hand. Let's plug them in, see what they look like in WinPlot. So I'm gonna do close that, I guess. I'll do a window, 3 dimensions. Do an equation and then choose curve. And I know you can't see this, but I'll just describe to you what I'm entering. So for the f or the x equals, we're going to put in a number before I, which is t squared. So I do t char 2. The y will be t. Y is whatever's before your j. And then whatever's before your k is going to be your z. So z is equal to 4. So put 4 in for z. Now for our low, I have 0. If I put the 0 in, let's leave that. Now put 3 for the t high. And click OK. Now if I do a view axis, if I rotate a little bit, you see it looks like that. But we know a t squared is supposed to look like a parabola. So I'm going to go back into edit. And why it didn't appear is because our t low is not correct. To set the t low, I'm going to change it to -3. And then click OK. So it really does benefit you to actually know what your graphs look like, what t squared looks like, because then you can see if you got it right. Okay, so there's our graph in 3D. Now this vector here, r of t naught, it's 4i plus 2j plus 4k. Well, we're going to do an equation and choose point, and then actually, I lied to you. Equation segment. Now, where it's heading from is the origin. So for A, B, and C, I'll put 0 in for each one. Now it's asking us for D, E, and F on this screen. Well, our D, E, and F will be the 4, 2, 4. So put in 4 for D, 2 for E, and 4 for F. 4, 2, 4. Okay. Now I'm going to click P2 to put a arrow there, and I'll change the arrow size to 14, and then click OK. Now if I rotate this a little bit, you see we got a starting at our origin, vector going out to our graph. Now for when that one left off, we want to draw another one. So I'm going to do equation and choose segment. Now that one left off at 424, so I'll put in 4 for A, 4 for A, 2 for B, and 4 for C. Now here, and I'm running on assumption, instructions don't say it, but it kind of goes right along with the first two problems. I'm running on assumption they want us to continue from where the first vector left off. So this is 4, and this is 4i plus j. So I'm going to add 4 plus 4 gives us 8. So I'll put 8 in for D. For E, this one is 2, and this one's 1, so 2 plus 1 is 3. So I'll put 3 in for E. And for F, see how we don't have a K component down here? So it just stays at 4. It doesn't change. So I'll put 4 in for F. I'll click P2 to put an arrow there. 14's good, and I'll click OK. And now if I rotate that, you can see at that particular point where the vector went that we got a so maybe I can get this graph to look. There we go. You can see we got a tangent to that point. So same idea. And again, the 3D, you can really see it best if you put into a utility like this and rotate it and understand what is going on. If you try to draw this by hand, you may get a graph that looks good, but you sure can't rotate it to get a better understanding of it. Okay, let's look at number 4. We got R of t equals t to the 4th I plus cube root of tj. Well, we need to rewrite that radical in fractional power form, rational exponents. So we got t to the 4th I plus t to the 1/3 j. So for our derivative, take your power, put it out in front, lower it by 1. So this is 4t to the 3rd I plus 1/3 t, lower that by 1. So 1/3 minus 1 gives us negative 2/3 j. That gives us 4t to the 3rd I. And I'll take the t to the negative 2/3 down to the denominator. So that's plus 1 over 3t to the 2/3 j. And that's our derivative. Let's look at number 5 here. R is equal to cosine to the 5th I plus sine to the 5th j, plus e to the negative t squared k. Now remember this, cosine to the 5th, what it really looks like is this right here, where we got cosine t to the 5th power. This is a chain rule. You got something to a power, parentheses to a power. So you take a power, put it out in front, lower this by 1, and then you multiply times derivative of what's inside the bracket. So for our derivative, take your power, put it out in front. This becomes cosine to the 4th times the derivative of cosine, which is negative sine I. And I'm kind of out of room there, but let me put it right here. Plus, we'll do the same thing with sine to the 5th. So we got 5 sine to the 4th t, and times the derivative of sine, which is cosine, j, plus the derivative of e to a power is e to the power, that doesn't change, times derivative of the power. So times the derivative of negative t squared is negative 2t. Okay. So our derivative, the negative I'll put out in front, so we got negative 5 cosine of the fourth t sine t I plus 5 sine to the fourth cosine t j. And then I'll put that out in front, so we got minus 2t e to the negative t squared k. And that's our answer. Number 6. R is going to equal to, and again, this is still a vector, vector valued function, I should say. It's just in this form. So we've got t squared cosine t, comma, square root of t, comma, 5t. Well, let me rewrite this. So this will be t squared cosine t, and square root of t is t to the 1/2, and then 5t. And we want to take the derivative of each component function. So this will be the product rule. This will be p, and this will be q. P prime, the derivative of t squared is 2t, and q prime, the derivative of cosine is negative sine t. And our formula is p prime q plus p q prime. So our derivative, p prime was 2t times q, which is cosine t, plus p, which was t squared, times q prime, which is negative sine t, comma, t to the 1/2. Take your power, put it out in front, so we got 1/2 t, and then you lower your power by 1, so it becomes a negative 1/2, comma, then derivative of 5t is 5. So we got 2t cosine t minus t squared sine t, and this is 1 over 2t to the positive 1/2, comma, 5. And that's our answer. And let me save that. There we go. And let's look at our next problem. So I got r is equal to t to the 4th I minus t squared minus 1 j. And we want to find our first derivative, second derivative, and then we find a dot product of those two. So for A, we want to find r prime. Derivative, and take derivative of the component functions just like before. So this becomes 4t to the 3rd I. And the derivative of t squared is 2t, so this becomes minus 2t j. Now for our second derivative, we're going to take what we just found and take derivative of it. So 4t to the 3rd becomes 12t squared I minus the derivative of 2t is 2 and then a j. Then the dot product of our first derivative and our second derivative. Well, the dot product, you multiply the what's in front of your eyes. So I'm going to have 4t to the 3rd times 12t squared plus, and then you multiply what's in front of your j's. So I got negative 2t times negative 2. 4 times 12 is 48. T to the third times t squared gives you t to the fifth, plus negative 2 times negative 2 is 4, so this gives us 4t. And that's our answer. Or I guess I should say answers for that problem. Let's take a look at this one. And I'll do it down here. It's a little bit longer problem. So we got r is equal to cosine 2t, comma, sine 2t, comma, t e to the t. Now, I'm going to do this t e to the t over on the side, because we're going to need to find the derivative of that. This is the product rule. This will be my p, and this will be my q. P prime, the derivative of t is 1. Q prime, the derivative of e to the t is e to the t. So we got p prime q plus p q prime. P prime is 1 times q, which is e to the t, plus p, which is t, times q prime, which is e to the t. So that's going to give us e to the t plus t e to the t. Okay, so for our first derivative, the derivative of cosine is negative sine, but since this is more than a single t in here, we have to multiply times the derivative of this. Well, the derivative of 2t is a 2, so this is going to become negative 2 sine 2t. Now the derivative of sine is cosine, but since we have more than a single t here, we have to multiply it times the derivative of 2t, which is, again, 2. So this becomes 2 cosine 2t. And the derivative of this is this over here. So this becomes e to the t plus t e to the t. We want to take derivative again. The first parts are pretty easy, sine and cosine, but the second part, let's take a look at it. We got e to the t plus t e to the t. Well, this first part here, the derivative of e to the t is e to the t. The derivative of t e to the t, we just found up here, which is equal to this. So this is going to be plus e to the t, e to the, try it again. It's looking at the wrong line. Okay, this one. Plus t e to the t. So this is our derivative. We took the derivative of this with respect to t. E to the t plus e to the t gives you 2 e to the t plus t e to the t. Okay, so for our second derivative, the derivative of sine is cosine, but again we have to multiply times the derivative of 2t, which is 2. So I throw another 2 in the mix. So this becomes negative 4 cosine 2t. The derivative of cosine is negative sine, but again we have another 2 in there. So this becomes a negative 4 sine 2t. And the derivative of e to the t plus t e to the t is down here. So this becomes 2 e to the t plus t e to the t. Okay, so this is part A, finding this. Part B is finding our second derivative. And then the last part is finding the dot product of those. Now remember the dot product, we multiply what's in front of your, well actually this there's no I here, but this is implied I, J, K. So we multiply our first parts together. So negative 2 times negative 4 gives us 8 sine and cosine. So we've got sine 2t, cosine 2t. And multiply our second parts together. 2 times negative 4 is negative 8, and then we've got a sine and cosine again. So we've got sine 2t, cosine 2t. And then multiply these two together. So we've got plus e to the t plus t e to the t times 2e to the t plus t e to the t. Well, the 8 sine cosine minus 8 sine cosine drops away, and we multiply these together. So we get 2e, and remember if you got like x squared times x squared, you x squared times x squared, you add the exponents. Same thing here. T plus t is 2t. So this becomes 2e to the 2t. E to the t times t e to the t gives us t e to the 2t. T e to the t times 2e to the t gives us plus 2t e to the 2t. And t e to the t times t e to the t times t is t squared, and that gives us e to t. Okay, here we got a t e to the 2t and 2t e to the 2t. See, these are the same, so you add numbers out in front of them. We got invisible 1 here and 2 here, so that gives us 3 t e to the 2t plus t squared e to the 2t. Now, if I had to guess, they probably factor out the e to the 2t since they have it in common. So I'll bring out e to the 2t, and that leaves us 2 plus 3t plus t squared. Assuming I didn't make a basic algebra mistake somewhere. Yeah, let's take a look at our next problem. And I'm not sure if I have room to work it here, so let me save this. There we go. And number 9. This is asking us to find some unit vectors. So we got r of t is equal to cosine t I, plus sine t j plus t to the third k. And t naught is going to equal to pi over 2. Now, we need our first derivative and second derivative for these formulas. So let's do that first. So for our first derivative, the derivative of cosine is negative sine, so this will be a negative sine t I. Derivative of sine is cosine, so it becomes plus cosine tj. And derivative of this gives us 3t squared k. For our second derivative, derivative of negative sine gives us negative cosine. The negative just stays out in front, and then derivative of sine is just cosine. The derivative of cosine is negative sine, so this becomes minus sine t j. And then derivative of 3t squared gives us 6t k. Now, we need to plug in t naught into these. So we're going to find our first derivative. We'll plug in t naught. T naught is pi over 2. So our first derivative, we'll plug in pi over 2 for the t. So we got negative sine pi over 2i plus cosine pi over 2j plus 3 times pi over 2 squared k. Now, sine of pi over 2 is 1, so this gives us negative 1i, or just negative I. Cosine of pi over 2 is 0, so that drops away. And I'm going to square this, so that gives us plus 3 pi squared over 4k. Now we also need to plug in t naught into our second derivative. So we'll plug in pi over 2 into that. And here's our second derivative. So we're going to have negative cosine of pi over 2 I minus sine pi over 2j plus 6 times pi over 2k. So again, I just replace the t's with pi over 2. Well, cosine of pi over 2 is 0, so negative 0 times I is 0. Sine pi over 2 is 1, so this gives us negative 1j, or negative j. And then 6 divided by 2 is 3, so it gives us plus 3 pi k. Okay, now we're ready to find our unit vectors. And the first one they're saying to find is this one right here. So r prime of t naught over magnitude like that. Well, r prime of t naught is this right here. So we're going to have negative I plus 3 pi squared over 4k over, and remember with this, we take the square root, and then we're going to take each component function, square it, and then add them together. So the what's before my I here is a negative 1. So we're going to have negative 1 squared plus, and what's before our k is 3 pi squared over 4 squared. So that gives us negative I plus 3 pi squared over 4k. And negative 1 squared is 1 plus, you square all this, that gives us 9 pi to the 4th over 16. And not a whole lot of simplifying I can do. I can bring out a 1/16, and that gives me a 1/4 here. So it gives me negative I plus 3 pi squared over 4k. And bring out a 1/4. When I factor out a 1/16, this becomes 16. So this becomes 16 plus 9 pi to the 4th. Now I could multiply everything by 4, so it would give us negative 4i plus 3 pi squared k over square root of 16 plus 9 pi to the 4th. And that's about as far as I'm going to simplify it. I could take it further, but it's probably not really worth the effort on that. Now for our other unit vector. That's for a second derivative. Okay, our second derivative is this right here, negative j plus 3 pi k over, and again we're going to take the square root, square the component functions, so this is negative 1 squared plus 3 pi squared, and we're adding them together. So that gives us negative j plus 3 pi k over negative 1 squared is 1 plus 9 pi squared. Again, I'm not going to simplify any further than that. That's good enough for this particular problem. Now, the next item that we're going to talk about is a smooth curve. Given a vector-valued function, r of t is equal to f of ti plus g of tj plus h of tk, and ij and k are vectors. Those are correspond to our unit vectors. And then the r of t, that's a vector. F of t, g of t, h of t are component functions. And it's smooth on the open interval I if f prime, g prime, and h prime are continuous on I. And the derivative of r is not equal to the 0 vector. Now this is not just 0, this is a 0 vector for any value of t in the interval I. So let's look at a problem and see what in the world they're talking about. So we got r equal to t to the fourth I plus 3t squared j. And this I just copied down out of the book. Hopefully I copied it down correctly. But this implies that we need to find our derivative. Because if we find the derivative of the vector valued function, we do that by finding the derivative of each of these component functions. So, for our derivative, t to the fourth becomes 4t to the third I plus, and take 2 out in front here, and you get 6tj. Okay. Smooth on the open interval if f prime, g prime, and h prime are continuous on I. So we look where these are discontinuous. Well, there's the places where you have a something discontinuous is when you have a fraction. You got a t in the denominator. We have a radical with an even index, like square root of t. If you have a piecewise function, that's another place. This is these are both, this component function and this component function are continuous everywhere, so we're fine there. Then they say, and r prime is not equal to the 0 vector. So what we're going to do is we're going to set each component function equal to 0 and then solve it. So we'll set 4t third equal to 0 and 6t equals 0. Now when I solve each one of these, this one the 4 drops away, the third power drops away, we get t is equal to 0. This one, divide both sides by 6, you get t is equal to 0. If these are the same, see how these are both t equals 0? So if you get them the same for all of your component functions, this is where it's not smooth. So it's not smooth at t is equal to 0. Which means our answer, it's smooth from negative infinity to 0, union 0 to positive infinity. Let me save that. And let's look at our next problem. Okay, number 11. We've got r is equal to cosine to the fifth t I plus sine to the third j. Keep in mind, this is saying that we got cosine t to the fifth power. So when taking the derivative of that, take your power, put it up in front. What's inside the parentheses remains as is. Lower your power by 1, and then you multiply times the derivative of what's inside the parentheses. So that's a setup on that. Okay, so for our derivative, this becomes 5 cosine t, cosine to the fourth, and then we multiply times the derivative of cosine, which is negative sine. And that's I. And our one over here, this is the same idea. Take your power, put it out in front, so we've got 3 sine squared t, and then we multiply times the derivative of sine, which is cosine j. Okay. Now, if I look at sine and cosine on both of these, if I go back to my definition here, F prime, G prime, and H prime are continuous everywhere because cosine and sine are continuous everywhere. There's no place where they're not defined. The question is, if there's some kind of value that causes this equals 0 and this is equal to 0. Well, let's set this first component function equal to 0. So I got negative 5 cosine to the fourth t sine t is equal to 0. And I'll set 3 sine squared t cosine t equal to 0. So I set each component function equal to 0. Now I could divide both sides by negative 5 to get rid of that. So the only things we're interested in is the cosine and sine. So I'll set cosine to the fourth t equal to 0 and sine t equal to 0. Well, the fourth power drops away, and we got cosine t is equal to 0 and sine t is equal to 0. Well, if I go around my unit circle, and where sine and cosine are both equal to 0, would be at t is equal to 0, pi over 2, pi, 3 pi over 2, and 2 pi. Same thing here. Drop the 3, set each one of these equal to 0. So I got sine squared t equal to 0. And cosine t is equal to 0. Which would give us sine t is equal to 0 and cosine t is equal to 0. Which gives us the same values. So you got t is equal to 0, pi over 2, pi, 3 pi over 2, and 2 pi. Now, and this keeps going forever, by the way, and this one does too. And they both have the same values. You notice where it's not smooth at is where these have the same values. So it's not smooth at 0, and I'm going to put this in a different form, 0 pi over 2, 1 pi over 2, 2 pi over 2, which is pi, 3 pi over 2, 4 pi over 2, which is 2 pi. And I think you see the pattern when I put it in this form. There's different ways you can write this. This book uses a notation, which is kind of nice. They use like n pi over 2, and then this will be n plus 1 pi over 2. N is an integer. This would encompass everything except for these values. So this is smooth here. Now I could equally write it a little bit easier. I could say it's not smooth at t is equal to n pi over 2, and n is an integer. Different ways you could write it. I'm going to circle this as our answer, though. And let's look at our next problem. That one we did. That one we did. Okay, this one. So we got R, which is equal to 1 over t minus 2I plus t squared j plus tk. And let's go back up to our definition. We need to find derivative, so r prime. Keep in mind this one right here is the same as t minus 2 to the negative 1 power, I, plus t squared j plus tk. So for our first derivative, this is the, we got parentheses to a power, take a power, put it out in front, so this becomes negative 1. What's inside the parentheses remains as is, lower your power by 1, so that's negative 2, times the derivative of what's inside. Well, the derivative of t minus 2 is just 1. I plus t squared becomes 2t j, and t becomes 1 k. So this gives us negative 1 over t minus 2 squared. Take that back downstairs. I plus 2tj plus k. Okay. So we look to where f prime, g prime, and h prime are discontinuous. And it's not smooth there. Well, these two are okay. 2t and this like the invisible 1. So those two are fine. But this one has a fraction. And remember we set our denominator equal to 0. So I'll set t minus 2, well, t minus 2 squared equal to 0, which then becomes t minus 2 equals 0. So we get t is equal to 2. So this is where it's discontinuous. So it's discontinuous at t is equal to 2, which means it's not smooth there. Okay, then the second part says see if we can set it equal to the 0 vector. So I'm going to set each one of these component functions equal to 0 and solve them. So here I got negative 1 over t minus 2 squared equal to 0. I'll set 2t equal to 0, and I'll set 1 equal to 0. Obviously, they're not going to have anything in common. This gives us t equals 0. Here, if I multiply both sides by t minus 2 squared, I'm going to get negative 1 equal to 0. And here we got 1 equal to 0, so those cross off. And obviously, all three of them don't have the same value. So from this perspective, it's okay everywhere. So the only place we have a problem is right here. So our answer on this one, smooth from negative infinity to 2, union 2 to positive infinity. And that's our answer. Let's save this. And let's look at our next problem. Number 13. I got quite a few things I want us to find here. So we got r is equal to 4t I plus t to the third j plus 5t k, and u is equal to t squared I plus tj plus 6t k. First thing I just want us to find is the first derivative of r. That's easy. So the derivative of r, 4t becomes 4, so we got 4i plus 3t squared j plus 5k. Part B, find our second derivative. So for our second derivative, we'll take the one we just found and take derivative again. Now the derivative of 4 is 0, so that's 0i, so it drops away. 3t squared becomes 6t j. And 5, the derivative of 5 is 0, so that drops away. So this would be our second derivative. Okay, C. For C, we want to first find the dot product of r and u. Should have had these bold, but oh well. Okay, r and u. So let's find that first. So we've got dot product of r and u. We multiply what's in front of our i's. So we got 4t times t squared. So 4t times t squared. Plus, then we multiply what's in front of our j's. So we got t to the third times t. So t to the third times t. And then we multiply what's out in front of our k's. Sorry, 5t times 6t. Well, this gives us 4t to the third. This one gives us t to the fourth. And this one gives us 30t squared. Well, then they want us to take the derivative of that. So we'll take derivative of the dot product. So the derivative of, with respect to t, of 4t to the third plus t to the fourth plus 30t squared is going to give us 12t squared plus 4t to the third plus 60t. And I can rearrange that so it's in standard form, but we'll call that good right there for part C. Now D says we got 3 times r minus u, and then we want to take derivative of it. So let's first find 3 times r minus u. And these are, okay, no derivatives. Well, we got 3 times r, which r is this up here. So we got 4ti plus t to the third j plus 5tk minus u. And u was t squared I plus tj plus 6tk. Well, 3 times 4 gives us 12. So we've got 12ti. 3 times t to the third gives us 3t to the third j. 3 times 5 gives us 15tk. And this negative flips the sign of everything here. So that becomes a negative t squared I minus tj minus 6tk. Well, we want to combine together the i's. So I got 12t minus t squared. So this is 12t minus t squared I. Combine together the j's. So I got plus 3t to the third. And j over here is negative t. So 3t to the third minus t, j. And let me make that a little bit more legible. Then the k's. We're going to have 15t minus 6t. That one can actually simplify a little bit. So this becomes 12t minus t squared I plus 3t to the third minus t j. 15t minus 6t gives us 9t. So 9tk. Well, then we want to find derivative of it. So I'm not going to write it all out, but the derivative of that, if I take derivative of what's in front of my I got 12 minus 2t I. Take derivative of what's in front of our j. So that, again, what I'm doing is taking my power and putting it out in front. So 3 times 3 is 9. So that's 9t squared minus 1j plus 9k. And assuming I didn't make a basic algebra mistake somewhere, that would be our answer. Now E. We want to find the cross product and then take derivative of it. So R and U. So find the cross product of those. Now remember the cross product, our top part is always our I, J, K. Next one is R, which is first. So we put R in our second row. And R was 4t. Put the component functions down. T to the third and 5t. And then our u is second, so we're going to put our u in the last row. And u is t squared, t squared, t and 6t. Okay, let's see what this gives us. If you remember the cross product, I start with the I, and I cross out the row and column it's in, and then I have this determinant. So I'll take t to the third times 6t, that gives us 6t to the fourth, minus t times 5t, which is 5t squared, and then I. So again, I cross out that row and that column where the I is, and then I took the determinant of what's left here. Now, the way the signs go, this will be positive, this will be negative, and this will be positive. So we're going to have a minus, and then, again, I cross out the row and column it's in, and what's left I find the determinant of. 4t times 6t gives us 24t squared, minus t squared times 5t gives us 5t to the third, j, plus, and working with the k, so I'm crossing out the row and column it's in. And we've got 4t times t gives us 4t squared, minus t squared times t to the third is t to the fifth. Okay. Okay. Well, now we want to find the derivative of that. And I'm not going to write the notation down again. Derivative of that takes the derivative of each component function. So this gives us 24t to the third minus 10t I minus 48t minus 15t squared j plus 8t minus 5t to the fourth k. And that's our answer to that part. F. I might have room here, hopefully. This says we want to the magnitude of r. So let's find that first. And remember, that's a square root, and then we take our component functions, square them, and add them together. So r was 4t, so we're going to have 4t squared plus t to the third squared plus 5t squared. Boy, derivative of that's could be kind of nasty. Is that what we're finding? Yeah, derivative of that. Well, this gives us 16t squared. This gives us 25t squared. 16 plus 25 is 41, I think. We'll pretend it is. Yeah, 41. T squared. And this is, when you're raising one exponent to another exponent, you multiply them together. So that's going to be t to the 6. Like that. Now, the derivative of that. Well, this is the same as writing it as 41t squared plus t to the 6 to the 1/2 power. Taking the derivative with respect to t, this is parentheses to a power, chain rule. Take your 1/2, put it out in front. What's inside the parentheses remains as is, so this is 41t squared plus t to the 6. Lower your power by 1, so it becomes negative 1/2. And then times the derivative of what's inside. So that gives us 82t plus 6t to the 5th. And the negative 1/2, I'm going to take all that down to the denominator. So we're going to have... now see how we have a 2 here? And 82 and 6? Those are going to simplify. So that 2 is going to disappear there. And this becomes 41t plus 3t to the 5th over, and the 1/2 power, when I take it down below, that's a square root. So 41t squared plus t to the 6. And again, assuming no basic math error, that's our answer. So let's save that. Kind of a long problem that one was. Now they got some formulas for handling derivatives and cross products and so forth. And when I looked at them and tried them on a few problems, I didn't see where they saved a lot of work. But on some problems they might. So that's up to you whether you want to use them. I'm not going to force you to. Now this one is telling us to use the definition of the derivative to find r prime. So let's see what in the world that's referring to. Okay, so we got r is equal to 5t minus 1 I plus t squared j. Now we need to find r of t plus delta t. So we're going to go through and we're going to put t plus delta t in everywhere we have a t in our problem up here. So we're going to have 5 times t plus delta t minus 1. That's I. Then plus, and we're going to have t plus delta t squared j. Well, we're going to have 5 times t is 5t. 5 times delta t is 5 delta t minus 1, I. And when I take t plus delta t times t plus delta t, I'm going to get t squared plus 2t delta t plus delta t squared j. When I FOIL this. Well, our formula for the derivative is equal to this right here. T plus delta t minus r of t over, and I left something off. Try it again. You need our limit here. Limit as delta t goes to 0 of f of t plus delta t minus f of t over delta t. So that's equal limit as delta t goes to 0. F of t plus delta t we said is all of this. So this becomes 5t plus 5 delta t minus 1 I plus t squared plus 2t delta t plus delta t squared j minus why am I putting f of t there? That should be r of. Try it again. I'll eventually get it. There we go. R, and that's r. Minus r of t, which is this right here. So we're going to have 5t minus 1 I plus t squared j all over delta t. Okay. So we're going to have 5t plus 5 delta t minus 1 I plus t squared plus 2t delta t plus delta t squared j. And this negative, I'm going to go ahead and carry it through. So we're going to have a plus, and then we'll have negative 5t plus 1 I minus t squared j over delta t. Okay. Now here we got 5ti. So this 5ti and this negative 5ti going to cancel. Here we got negative 1i, and here we got a positive 1i. Those going to cancel. Over here we got a t squared j, and here we got negative t squared j. So those t squared is going to cancel. So we're left with limit as delta t goes to 0, and we got 5 delta ti, so 5 delta ti, then plus 2t delta t plus delta t squared j. Those are all gone, so those disappeared, over delta t. And I sure hope I don't make an algebra mistake here. These aren't necessarily that easy, doing it by the definition. So limit as delta t goes to 0, and I'm going to factor out a delta t. And that gives us 5i plus 2t plus delta t j over delta t. Well, those delta t's are going to cancel. This one cancels with this one. And we got limit as delta t goes to 0 of 5i plus 2t plus delta t j. And now we're ready to plug 0 in for delta t. So if we put 0 there, I'm going to have 5i plus 2t plus 0 j. So that's going to give us 5i plus 2t j. 5i plus 2tj. See, if I take the derivative of 5t minus 1, that gives us 5i, which is this. The derivative of t squared is 2t, so that'd be 2tj, which will give us this. So this is using the limit, or definition derivative, sorry. Past my bedtime. Oh. Let's take a look at the next problem. This is integration. Let's see how these work. And do I got room? Yeah, probably got room. It's pretty much like you'd expect. So I got 3ti, the integral of it, plus j, minus 2k, with respect to t. Well, you add 1 to your power, divide by new power. So this becomes 3/2 t squared I plus, and that's like a 1 here, so this becomes tj minus, and this again is like a number, so this becomes minus 2tk. I actually had 2 numbers on that one? Yeah, I did, didn't I? And then we have plus c here at the end. Now c here is not a number, it's a vector. So this is our constant vector. And that would be your answer. And let me save that. Yeah, let's look at our next problem. Number 16. There we got the integral of the cube root of ti plus sine t j minus e to the 2t minus 1 k dt. Now we're treating each one of the component functions separately. So if you need to split them up, then do so. If it helps you to see how to find the integral. So this would be keeping in mind that we have to have our constant vector thrown on at the end. This would be t to the 1/3 I respect to t. This one would be sine t j with respect to t minus, and then this would be e to the 2t minus 1 k with respect to t. These first two are pretty easy. This is a u substitution here, though, since we got more than e to the t power. So we'll set u equal to the exponent, which is 2t minus 1. du would be 2 dt. So we need a 2 inside, so we put 1/2 on the outside. I'm going to go ahead and find these. Add 1 to your power. So we got t to the 1/3 plus 1 over 1/3 plus 1 I. For sine, going backwards, this gives us negative cosine. So this is minus cosine t j. And we said we needed a 2 inside, so we'll put a 1/2 on the outside. So 1/2, and then 2e to the 2t minus 1 k. And like this. And let's see, this becomes 4/3. So this is 3/4 t to the 4/3 I minus cosine t j. And then this becomes minus 1/2. The integral of the 2 dt disappears, becomes du, and this becomes e to the u. So e to the u k du. So we've got 3/4 t to the 4/3 I minus cosine t j. And the integral of e to the u is e to the u, so minus 1/2 e to the u k. And I'm going to go ahead and put my constant vector on here, like that. Okay, so this becomes 3/4 t to the 4/3 I minus cosine t j minus 1/2, and I'll plug my u back in. U is 2t minus 1 k, and then plus c. And that's our answer. Do I have room? Probably do, but let me start a new page just in case. There we go. Now here we got a definite integral. So we're going to go from 0 to 4. And we've got t squared I plus square root of t j minus tk with respect to t. Okay. So then this becomes, now this is the square root of t is t to the 1/2 power. So we'll add 1 to our power, divide by our new power. So this gives us 1/3 t to the 3rd I. And this one becomes, again, this was t to the 1/2 power. So we add 1 to our power, divide by our new power, j, minus, add 1 to your power, divide by new power, so minus 1/2 t squared, k, 0 to 4. So this gives us 1/3 t to the 3rd I, and 1/2 plus 1, that gives us 3/2. So this becomes plus 2/3 t to the 3/2, j, minus 1/2 t squared k. Okay, now we're going to plug these in. 0 drops away. We have 0 to the 3rd, that's 0. 0 to the 3/2, that's 0. 0 squared is 0. So all of these drop away for the 0 part. So all we have to worry about is the 4. So plug in 4 for the t. So we've got 1/3 times 4 to the third I plus 2/3 times 4 to the 3/2 j minus 1/2 times 4 squared k. 16 times 4 is 64, so we got 64/3 I. Now 4 to the 3/2 power. If you remember this from intermediate algebra, you can rewrite this as 4 to the 1/2 to the third power. 4 to the 1/2 is the square root of 4. So that gives us 2 to the third, or gives us 8. So this is 8 times 2 gives us 16/3 j. And 4 squared is 16, divided by 2 is 8, so we got minus 8k. Okay. Our next problem. We got r prime is equal to 9 e to the 3t I minus tj, and r of 0 is equal to 2j. It says find r for the given conditions. So to go backwards, we're going to find r by taking the integral of r prime. So the integral of 9e to the 3t I minus t j dt. And I'm going to split this up into separate pieces so we see it a little bit easier. So this is, and I can put the 9 out in front of this one. So we got integral, or 9 times the integral of e to the 3t I dt minus the integral of t j dt. Now this is a u substitution again. So we got u is equal to 3t, du would be 3 dt. So we want a 3 inside, and we offset it with a 1/3 out in front. So we got 9 times 1/3, then 3e to the 3ti dt, minus, add 1 to our power, divide by our new power, so that's 1/2 t squared j. I'll put the plus c on here in a minute. Okay, 9 times 1/3 is 3. And then this becomes e to the u I du minus 1/2 t squared j. Okay, the integral of e to the u is e to the u, so 3e to the ui, and minus 1/2 t squared j. And I'll put on my plus c on here now. And then I'll put that notation back in. U, we said, was 3t, so plug that in. Make it a little bit neater so you can see it. That's 3e to the 3t I minus 1/2 t squared j plus a constant vector. Now we said that r of 0 is equal to 2j. What does that mean? Well, this is saying right here, this is 0 and here is t. So we're going to plug 0 in for t. And if we do that, then this side is going to equal to 2j. So we're going to have 2j over on this side. And we put 0 in for the t here. So we've got 3e to the 3 times 0 I minus 1/2 times 0 squared j plus c. So we've got 2j equals 3 times 0 is 0, e to the 0 is 1, so this gives us 3i. 0 squared is 0 times 1/2 is 0, so all that drops away, plus c. I really thought that one would work out differently. Let me just double check myself here real quick. So plug 0 in for that. That's going to go away. I mean, it's fine the way it came out, but now I'm solving for c, so I'm going to take 3i over. So I got negative 3i plus 2j equals c. So we found out what this constant vector is. So back up to here, this part right here now becomes r is equal to 3e to the 3ti minus 1/2 t squared j plus c. So we got minus 3i plus 2j. That's our c we just found. Now we're going to merge together the i's and the j's, and I'm out of room. Oh, that's great. Right here. So this is going to equal to, again, this I and this I I'm going to merge together, so I'm going to have 3e to the 3t minus 3i, and I'll merge together the j's. So plus negative 1/2 t squared plus 2j. And that's our answer. Guess I should start a new page. So let me start a new page now. Then we'll look at our last problem. This is very similar to the one we just did. Number 19. So r prime is equal to t e to the ti minus t squared j plus 3k, and r of 0 is going to equal to 4i plus 2j minus k. Okay, so to find r, again we're going to take the integral of r prime. So an integral of t e to the ti minus t squared j plus 3k with respect to t. Now this is by parts, and I wanted to refresh your memory on it, so that's why I chose this. Now for the t e to the t is going to be our derivative portion, so we'll put t there, and the integral will be e to the t. And our sign, remember, this starts at plus. Now the derivative of t is 1. The derivative of 1 is 0. This is negative, positive. The integral of e to the t is e to the t. The integral of e to the t is e to the t. Okay, so we're going to go across here. That sign goes with this, and then that goes down to here. This sign goes with that, and then that goes down to there. So, r of t. The integral of this piece right here is going to be a positive t times e to the t. So we got t e to the t minus 1 times e to the t. So minus e to the t and then I. Minus, add 1 to your power, divide by your power, so that's 1/3 t to the third j plus, and this would be 3tk. And then we have our constant vector on at the end. Okay, so this says if we put 0 in, or we're going to use this initial condition here to find out what c is. So we're going to put 0 in for t. And then the left side is going to equal to 4i plus 2j minus k. Let me go down a little bit so I can have some room. So the left side, this right here, is going to be 4i plus 2j minus k equals, and we'll put 0 in for the t. Because again, that's what's inside of parentheses here. This is your t. So we got 0 times e to the 0 minus e to the 0 I minus 1/3 times 0 to the third j plus 3 times 0 k plus c. So we've got 4i plus 2j minus k. Now 0 times anything drops away, and e to the 0 is 1, so we've got negative 1 times I, or just negative I. This 0 to the third, 0 times 1/3 is 0, so I drops away, this drops away, and we got plus c. This one actually works out nice. Now I'm going to take that negative I over the left side, so we get 4i plus I plus 2j minus k equals c. 4i plus I gives us 5i plus 2j minus k equals c. So this right here, we now know what that constant vector is at the end. So this now becomes r is equal to t e to the t minus e to the ti minus 1/3 t to the third j plus 3t k, and then our c is this right here. So we got plus 5i plus 2j minus k. And we're going to merge together the i's. So this gets merged with this. So this becomes t e to the t minus e to the t plus 5i. We're going to merge together the j's, so this gets merged with this. So we got negative 1/3 t to the third plus 2j. And we'll merge together the k's, so those get merged together. So we're going to have 3t minus 1 k. And that's our answer. Assuming no basic math errors or basic algebra errors in this, which the probability that I made one somewhere in this video is pretty high, if I had to guess. So my eyes do cross and so forth, but I think you get the general idea. And this is our 10th page. There we go. I'm pretty sure that was the last problem. Yeah, it was. So let me stop the recorders. And stop the other recorder too.